Hey everyone, I hope you all are safe and doing good. So, today I'm going to start one of the most important topics in DSA, that is dynamic programming. Many students fear it because of its name, dynamic programming, and they feel that it's tough. But that's not true. It's not tough, it's just another way, or you can say algorithm paradigm or a technique to solve problems. Like we have discussed greedy, divide and conquer. You have binary search, you have branch and bound, you have backtracking. Same. It's an algorithm design technique. Yeah, little bit tricky. But once you get the base of dynamic programming, you are done. It's really easy for you. But prerequisite for this is to understand dynamic programming or DP is what you need to understand recursion first. So if you haven't watched my recursion videos, please go and complete that chapter first and then come to this. Because if you don't know recursion, you will not get it. Once you are good in recursion, it will be really easy for you to get dynamic programming. Okay, so that is prerequisite to understand DP. Now, what is DP? I've told you it's just a technique or algorithm paradigm which is used to solve which problem? Optimization problems. You know what is optimization problem? Greedy technique is used to solve optimization problem. We have discussed this thing. What are optimization problems? A problem which is having many feasible solutions. There is a problem P having many solutions. Out of these, few solutions are feasible solutions, right? And from these feasible solutions, you have to get the best solution, or you can say the optimal solution. So the problem will have only one optimal solution, and the goal is to find out that solution. This problem will be having what? Constraint. Some constraint will be given to you plus objective. Some constraints is given, some objective you have. Objective is either to maximize or minimize. Maximize or minimize. There are two kind of optimization problem, maximization or minimization problem. This thing we have seen in detail in that video, introduction to greedy algorithm. And to solve these kind of problems, optimization problems, we have many techniques like greedy, dynamic programming, branch and bound, backtracking. So greedy we have already uh, discussed. Now we see dynamic programming and how dynamic programming is different from greedy. So what is exactly the approach of dynamic programming is I'll discuss in this lecture. Okay, you understand? Now this is a technique which is used to solve optimization problems. It's a problem which is having many feasible solution. Out of these feasible solutions, your goal is to find out the best or optimal solution, best in the form of maximum or minimum. Like you have to find out shortest route, minimum time, maximum efficiency, maximum effort, or minimum cost. In these kind of problems, these are optimization problems, right? Okay. Now, how greedy solve these problems? Greedy approach. Greedy approach was what? At every stage, at every point, we choose the best uh, choice, or we can say we take the locally something like this. We choose locally at that time the best option or the best candidate, and we just hope that we move forward, and we just hope that it will lead to a global optimal solution, like shortest path from uh, A to B. Like there are many routes through which we can go from A to B. You have to find out shortest path. So what we do, from A I can go to this, to this, to this. So whichever this, at this point I am at this point source. So the shortest, whatever the shortest distance, I will select that. I'm greedy here. So suppose this is 10 kilometer, this is 5, this is 20. So this one is shortest. So I will choose this. I'll move forward. At this point now, from this point, suppose I can go to here, I can go to here, I can go to here, or here, or here. Now, whatever the shortest, I will again choose that. Suppose this is one out of all these shortest, so I will choose this path. Then suppose this is also again one which is shortest, so I'll choose this path. So like this, at one particular point, wherever you are, I will select what? The minimum. Ultimately, you have to find out the shortest distance. So whatever the shortest distance from A to the next vertex where you can go, that I will select. So you are being greedy. But it doesn't guarantee that it will further works, that it will definitely lead to the optimal solution. It is not a guarantee. So greedy approach, what? Works for optimization problems, but not for all problems. Okay, that thing we have seen in coin problems. Now, how dynamic programming works? See, you have some feasible solutions. And if I say one thing, how you can get the best out of all the possible feasible solutions or possible solutions, I will find out all the feasible solutions and then compare all the feasible solutions or possible solution, you can say, and then choose best. Will you get the best or optimal solution? Yes, definitely. But the thing is, if you go with this approach that you find out all the possible solutions, feasible solutions, and compare them and then find out the best, for sure you will get best solution, but it's time consuming. Yes, it's time consuming. So that's kind of approach DP programming follows. Yes, to somewhat. I'm not saying exactly dynamic programming finds all the possible solutions, compare them, and find out the best. No, not exactly like this. Indirectly, it tries to find out all the possible solutions and select the best one at last. So, somewhat it is following this approach, DP programming. So, that's why DP will give you correct result for sure. Best one optimal solution DP will give you. Okay. So, to somewhat, I guess that this idea is clear to you. But DP will make it faster. That's why DP is a great approach by taking some decisions at every point. Okay, that we will see. When I solve the problem, you will get this thing. Okay, just a general overview what is DP and how DP is different from greedy approach. Let's take one example. Suppose you want to go from your home to office. Your home is here. You want to go to office, right? So at some point, it says that you are at a signal. So you are following greedy approach. You are following greedy. So it says that a road going to left right now at this point of time, it will take 5 minutes. Okay, a road going to right, it will take 10 minutes. So if you are being greedy, so you will choose definitely this greedy technique will choose this. Okay, this is shortest, having less time, and you have to reach from your home to office in minimum total time. So we'll take this path. But maybe this will have a traffic jam later of 30 minutes. So total time will be 35 if you choose this route. And in this route, if you take right now, it is a little bit slower. This route is right now faster, but later have traffic jam. This route is right now slower, but later there is no traffic jam. Suppose traffic is only for 5 minutes. Traffic you will get only for 5 minutes or 10 minutes. So this will give you a total of only 20 minutes. But because you are greedy, you chose this one. Because locally, right now, at this point of time, at this signal, what is best for me, I will choose that. What is best at that, I will choose that one. I don't care about future consequences and past. No, I'm being greedy at this point of time. That I guess you know. But ultimately, it leads to you have to give 35 minutes, and this route, if you would have chosen, it will be 20 minutes. That's greedy. But if for same thing, if you apply DP, then see how DP works. DP will check that okay, that's 5 plus later future consequences also DP will see. It take decisions that okay, later the traffic jam is 30, so it will become total time 35 minutes. Later in this route, traffic jam is only 10 minutes, it will take me 20 minutes. So using DP, you will choose this. So at every point, DP is also going to solve the problem in stages. In stages means divide the problem in sub problems and like that. And every step on every stage, some decision will be taken. Okay, like here I decide. Later, traffic jam is only 10 minutes. Right now, maybe it is slower, but total it will be optimal for me. So I will choose this. So it takes into account the future consequences or other things also, and then decide using DP technique. Follow this approach. Then decide. So at every point, some decisions are taken, and then ultimately you will reach to optimal solution. Okay. So DP is going to solve problem in stages, and every stage some decision is to be taken, and ultimately it will lead to a optimal solution. Only if whatever decisions you have taken, those are optimal. So the decision must be optimal at every stage, at every step you decide something, you take decisions. So those decisions must be optimal. Then only you will get optimal solution. So that's main approach of DP. In greedy, at every point we select some, but here we decide. We decide based on like other factors as well. So decide, here we decide means basically try to analyze all the feasible solutions, and then we prepare some data and then decide. Because obviously to take some decision, if you want to decide something, something like this, suppose there is a road and it's a having three lanes, and here also there is a cut. Suppose there is a cut, this road is going on. So basically like you can turn, you just go ahead and you can turn, and this is also a road and vehicles are coming in this way, from this we are going in this way. Okay, so suppose person A is in this lane, person is A is here, and suppose B is here, or kind of that, or maybe A or B both are here. So sometimes it happens that when we are in this lane, so this lane, it seems that this lane is going faster, right? So what B will do, B will decide that okay, this lane is going faster, so B will switch to this lane, to this lane. Okay, but A is not going to switch because B is greedy. This lane is going faster, I have to reach faster, so I'll switch to this lane. But the thing is, in this lane, most of the vehicles are those who wants to take this cut, take this cut. And sometimes it happens the traffic on this road is also like heavy. So the vehicles are not going to not are not able to take this turn so quickly. So that's why they stuck here. They stuck here. Now this lane is stuck and B is stuck here. But this lane obviously is going simply forward, forward, forward. So A will go like this. But because of greediness, B stuck here. Yes. But why B was, that's A was like following DP programming. A is not greedy. A is able to decide that okay, I will not switch in this lane because A knows after some time or after some distance there is a cut. So most of the vehicles are those who want to take cut in this lane, and sometimes it's not easy or it's not quick to take this cut. And I want to go straight, so better to stay in this lane or this lane, like that. Okay, but A was able to decide this thing because A knows about this cut. So in dynamic programming, I have told you that at every stage some decision is to be taken, right? So we take into account how decision can be taken, how you can decide something. If you have information, then only you can take. If A knows this thing that there is a cut and A is smart enough, so he can decide. So for taking decision, we need data or we need information. That's really important. The role of data or the information is really important in DP programming. Maybe B doesn't know that there is a cut, so he took this uh, turn or this lane, right? So that's why DP prepares data as well. While solving question, you will get this thing. You will get everything, whatever I'm saying in this video. Once we will start solving questions. Don't worry. If you're not getting these things, you just take an overview. But you will get about DP everything about whatever I'm saying in this video once we solve a question. So DP prepares data, generates data, generally in tabular data to take decisions. Prepare data while solving question, take decisions, and ultimately at every stage decision will be taken, and ultimately it will lead to an optimal solution. But the condition is the decision must be optimal. At every stage the decision must be optimal. If the decisions are not optimal, it will not lead to an optimal solution. That's basic, or you can say main approach of dynamic programming. And while preparing this data, this tabular data, DP consider all these possible solutions or feasible solutions. So then ultimately it will give you an optimal solution. I've told you na, that's how indirectly it is checking all the feasible solutions and get the best one. Because DP prepares data, and while preparing this data, it consider all these feasible solutions. Okay, that's why I'm saying that DP means in greedy, we directly go to an optimal solution. We don't explore these feasible solutions. We don't care about that because we are being greedy at every stage, and we just hope that we will lead to an optimal solution. So we directly go to that optimal solution. But in second case, in DP, I've told you, find out all the feasible solutions, compare them, and then find out the best solution. So that's kind of approach DP is following, but not exactly finding all the possible solutions. It's not obviously feasible. It's very time consuming. Okay. But while preparing data, the stabler data, which will help DP to take some decisions, optimal decisions at every stage. While preparing this data, it consider all the feasible solutions so that indirectly it's like it can monitor, or it can, you can say, generate, or it can, you can say, like or I would say indirectly, like this DP checks all the possible solutions, compare them, and find out the best solution. So to somewhat the approach is, I guess, clear to you. And this thing, that the decision at every stage must be optimal to get a optimal solution, this is known as principle of optimality. Principle of optimality. And DP follows this principle. Although it is written in some other words in algorithm books, that is optimal substructure. Okay. But that is principle of optimality. Principle of optimality means, principle of optimality says an optimal solution to a problem contains optimal solutions to its sub problems. So it's like, if you are going, suppose the shortest route you get from your home to office is you go to A, some intermediate location, then B, then office. That's the shortest route you get using dynamic programming from your home to office. Okay. Now, it says that the principle of optimality, it says that the best path from your home to office is this using DP. So the best path from A to office must be shortest. Best path from B to office must be shortest. The best path from A to B, from A to C must be shortest. That is what principle of optimality says. If suppose this from A to C, the path is not optimal, it's not shortest. So you find out some other route from A to C, you have to go to A to C. You find out some other route which is shortest than this one from A, B, C. Suppose from A, D, and C. This is shortest. It means the original solution from home to A to B to C to office, this was also not optimal. Right? Optimal solution, that's a big problem. Home to office, optimal solution to the problem, to a problem, contains, that is for sure, optimal solutions to its sub problem. Sub problem is what? From home to A, that is a sub problem. From A to B, that is also a sub problem. B to office, that is also a sub problem. Main problem is home to office. So all these sub problems must have optimal solution. If suppose A to C is not best or the shortest path, so there is some other path A to D which is shortest. So definitely the original path from home to office also not optimal, not shortest, not best. And this rules DP follows. This is principle of optimality rule. Okay. I think it is clear to you. But in books, it is written not in the form of principle of optimality. It is written that DP problems must have two conditions. Means the problem have two conditions, then only you can use DP to solve those problems. And what are those? What are those conditions? First is overlapping subproblems and optimal substructure. So DP is an optimization technique. It is used when a problem has these two conditions: overlapping subproblems and optimal substructure. This optimal substructure is nothing but the same thing, which is principle of optimality we have discussed. Optimal substructure means we use optimal results of subproblems to achieve the optimal solution of a bigger problem. And why DP use this approach, this principle of optimality? Because in DP we find out the solution of bigger problems or the big answer using small answer. solving small problems. So if the smaller answer is not optimal, how you can get the bigger answer optimal? So the smaller answers must be optimal. So if you are able to divide, because basically we divide the problem into sub problems in DP. That's what the main idea. So if those small sub problems should have optimal solution, then only you can get a global optimal solution. Okay, the problem must have these two things. That is optimal substructure. What is this overlapping sub problems? In divide and conquer technique, I have told you that if we divide and conquer means we divide the problem into sub problems, but these sub problems should be independent. These should not be overlapping. If these are overlapping, we use DP. If these are independent, we can simply use divide and conquer technique. Overlapping sub problem means what? See, let's take one example. You are very well aware about that Fibonacci series. How to find out Fibonacci series? I guess you know this thing. If I start writing this like 0, then 1. First two are 0 and 1. Then add this and this. Then 1. 1 plus 1, 2. 2 plus 1, 3. 5, 8, 13. And like this. This is Fibonacci series. Yes. So if I say find out fib of 6. Fibonacci series of 6. You know recursively how you can solve, because we have already done this. What is the formula to solve? We write f of n, or fib of n is f of n minus 1 plus f of n minus 2. That's how we solve. That's the recursive method or the formula to write down this thing. Okay, you get this thing because we have discussed this thing when we were discussing recursion. So you can go and check out this thing. Now this thing is, if you draw the recursive tree of this, so fib of 6. So basically fib of n minus 1, that is 5, and we call 4, n minus 2, that is 4. But that's recursive call. So first we call this and we further move this. While going backward, these right call, recursive call will be evaluated, right? So this is f of n minus 1, that is 4, and f of 3. This is, now we go in this direction again, f of 3 and f of 2. Again, this is f of 2 and f of 1. F of 2 will be f of 1 and f of 0. Now we stop because f of 0 is 1 and f of 1 is 1 and f of 0 is 0. So just add these two and it becomes 1. F of 2 is 1. It is 1. So 1 plus 1 is 2. Like this. Like this, when we reach to dead end, then we come back. Now after f of 3, right direction, f of 2. So this will be expanded. F of 1, again f of 0. This will give me 1. This will give me 0. So 1 plus 0 is equal to 1. So it will give me 1. 2 plus 1 is 3. So it will give me 3. Yes. Now when we go back, but right direction is right part, right, recursive call is still left. So we expand this. So when we expand this, it becomes f of 2, f of 1. So again expand this f of 2, it becomes f of 1, f of 0. F of 1, it's 1, it's 0. So 1 plus 1, it's 1. It's 1. 1 plus 1, it's 2. And 3 plus 2, it's 5. And then we explore this right direction, that is f of 4. Then we explore f of 4. It means f of 3 and f of 2. F of 3 is f of 2 and f of 1. Again, f of 2 is f of 1 and f of 0. That's how basically we draw recursive tree. That's how we do. But what is the problem here? Can you see? See, for f of 6, we have divided this into sub problems. That is, find out first f of 5 and f of 4. These are sub problems. Yes, but to find out f of 5, we again divide it. F of 4 and f of 3. So these are sub problems. F of 4, we have again divided. F of 3, f of 2. So these are sub problems. These are sub problems. Are these overlapping? Yes. See, you see here. See, check this. F of 3. Multiple times. We are calling this method passing same argument, passing same parameter, same data, that is 3, same argument, that is 3. F of 3 is here, here, here. See, multiple times. If I say f of 2, it's here, 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 here. Many times I have f of 2. So it means these are overlapping. These sub problems are overlapping. Yes, we can solve. Overlapping means it's not independent. They are not independent. They are overlapping because Same sub problems is solved multiple times. Is solved multiple times. See, same sub problems is solved multiple times. So that is kind of overlapping sub problems. Now, whenever we find out this and we go to dead end, so we get f of 2 is 1. Yes, but can I do this thing again? If I go back here, I go f of 2. Rather than expanding this, rather than calling f of 2, can I use the same 1 here? Because I have already calculated f of 2. Why you are calculating again f of 2? Why you are calculating again f of 2? But in recursion, you have to calculate it. Yes, so we can do one thing. What? Okay, store these results and use here 1 directly. Don't call it. Don't call it. Use 1. While we are going back, f of 3 will become 2. So suppose when we go back, here we are calling f of 3. Don't call it. Have you f of 3? Previously computed f of 3, this sub problem? Yes. And the result? Have you stored? Yes, I have stored. So directly use it. 2 here. Don't call it. So this tree will not be expanded. See how easy this will be. Yes. So this is nothing but dynamic programming. Dynamic programming, one approach of dynamic programming. I'll see you, there are two approaches of dynamic programming, but that is one. And like when we are storing this, something like this is known as memoization. Memoization. Okay. But don't worry, I'll tell you this thing in next lecture. That's just, I would just want to give you this example. These are the kind of overlapping sub problems. If the same sub problems you have to solve multiple times in the same question to get the answer of bigger problem, then that are overlapping problems. So if a problem is having these two conditions or these two characteristics, that it will have overlapping sub problems and it has optimal substructures. Okay, that you can divide the problem into sub problems and recursively you can find out the optimal solutions of these sub problems. This will ultimately lead to optimal solution of the main problem. So that is kind of optimal substructure of a problem. We say this thing. In that case, you apply DP to solve that problem. So yes, Fibonacci series. You can use recursion plus you can use DP. That's kind of a DP problem. You can use here DP to solve this. It will optimize the recursion because in recursion there are multiple calls. But if you save these answers, so directly no need to call further this, directly use the stored value. So it will drastically improve the time complexity. It will reduce. Suppose in this case time complexity is 2 raised to power n. So it will drastically maybe reduced to order of n. In some polynomial form it will give you. So it's kind of one more aspect of dynamic programming, or one important point you can say about a DP is what? It is optimization of recursion. Yes, it is optimization of recursion. In DP also we are going to break into sub problems. So recursively we are solving these sub problems. Okay, so recursion we need. But it's not compulsory that DP means you have to use recursion only. There is some other approach also, that also we'll see. Okay, but to somewhat overview of DP is clear to you. What is DP? How DP is different from greedy? It is used to solve optimization problems. What are optimization problem? How this is different from greedy? At every stage, DP try to solve problem in stages. At every stage, it take some decisions, and optimal decisions, and those decisions will lead to an optimal solution. The decision must be optimal to get an optimal solution ultimately. Okay, to take decisions we need data. So DP prepares while solving question. DP generates or prepare data as well, considering all the feasible solutions, and then find out the best optimal solution at last. So that's important to understand about DP. Okay, now in the next lecture I will tell you what are some approaches to solve question, DP approaches, or two techniques to solve problems. Okay, so that's it for this lecture. Now it's in the next lecture. Till then, bye bye, take care.